All right, let's talk statistics. Time for the fun stuff. I know you guys are sitting there saying, yeah, right. All right, section 1.3. I'm breaking this into videos because Tanya's probably shooting me over how late this video is going up because YouTube has been trying to process one lecture video from this morning all day. So what I'm going to do is I'm going to share the screen. So I'm hoping you can see this. If not, I apologize. I'll try to be descriptive. But we're going to talk about simple random sampling. And you guys can read part of this, but before administering, we need to identify a population we're targeting, and the process is done through that first line. Is what this whole thing's about. It is simple random sampling. All right. But that's our first fill in the blank. So let's talk about what is simple random sampling. It's what we want to do because we want to keep as random as possible. And it's a process of how we choose people to be in a survey. We can do it in multiple ways. I just now realize this handout has a typo on it. So it goes through and talks about if we don't do it. So if we're not random, the big key on that nice next paragraph is the fact if it is not random, when we obtain our sample, in other words, we've introduced bias, or more specifically, our whole thing is meaningless. It is meaningless. If we don't have proper, if we don't have a proper sample, then we didn't do it properly by being random as possible. That's the big key there. Gotta be random. Now, if we do it by convenience, because if you guys was to do a survey, that'd be convenient. You just the people you live with in the dorms or the people you're in the class with. There's the problem. That is a sampling of convenience. All right. Now, the next line is the number of individuals. And to me, I always kind of giggle about this. You know how I like to poke fun at us statisticians. The sample is always smaller than the population. Always. And if that's kind of my, I always kind of giggle about this. Is kind of like my duh. it'd be kind of weird if our sample was bigger than the total number of people that we were surveying, don't you think, or studying? That's a repeat on something I started last week. It's about the size, the symbols, sample size lowercase n, population size is represented by capital N. A frame is what we call a list of people. We call them the frame. So the list of a population or list of the individuals in a population, we can, it's what the proper term is. It's a frame. Crud. This is the reason why I really don't like teaching this way. All right. The next bit is if we do, it's called a sample without replacement, is when we select somebody out of the population to be in our sample and we don't put them back into the population. I tell people, think of like a deck of cards. You pull out a deck, you pull out a card and you keep it. It's considered pulling it without replacement. If you pull the card and put it back in, that is what we call a sample with replacement. Now, in a study, we can have a group of people and I can pull a sampling. And if I don't do a replacement, I keep shrinking my population for my next sample. And then I keep those people out and then I pull another sample. Again, population shrinks. Each time that I pull a sample without replacement, I am shrinking my population. And eventually I will get all of my population included. If I do a sample with replacement, when I pull my sample, there's a chance on my next sample, I might pick somebody up that was in the first sample again. And that happens. It happens. So let's talk about how we go about choosing the samples. We have all right. Yeah. Same thing. What the heck happened? It jumped when I accidentally did the thing. All right. Example one. We have 435 people, members in Congress, in the House of Representatives. And I want to do a sample of 5 members. Well, I could do what? Draw names, put all the names in a hat and draw names. I can use a random number generator. And that could be your calculator. piece of software like StatCrunch or a table. Well, we're going to look at the table. Trying to see, can I draw a line? No, it's not going to let me. Yep, it's not going to let me. To do this, I really need to be able to draw on this, and it's not going to let me do this. So I'm trying to think here real quick. How can I do this? You know what? Looking at your paper, and I'm hoping Mr. Toby's hearing this. If you can, underneath the document camera, you've got to be my pencil. Pencil and paper here, bud. I'm appreciating this more than you realize. We have to have a starting place, because if I don't give you a starting place, each and every one of us would pick a place as a starting point on the table and come up with all different numbers. So here, the starting point is row 3, column 6. So looking at row 3 starts 216. That is the row. Column 6 is going down, goes 169. It's where that row and that column cross is our starting point. So row 3, column 6 crosses at the 9. Until you're used to doing this, I tell you to draw a vertical line. And the vertical line would go right before column 6. So you'd put a vertical line just to the left of the column 169059, all the way down. Now, how many digits long is 435? It's 3. So in other words, all our numbers need to be at least 3 digits for a random number generator. So count over 3 digits from that first line, and you're going to draw another vertical line. And that'll go between the 2 4s on that top row. You see it? I'm hoping. It goes 450 and 496 is the top. Put it in between those all the way down. There is your 3 digits. You keep doing this, even if it means you have to jump a gap, because the next 3 digits, looking at the top row, would read 481. After that 1, draw a vertical line down. The next 3 digits would be 456, draw a line down. That should be enough columns for us to start. So we're going to look for 5 numbers, because we're wanting to invite 5 members, and we want to use a random number generator. To do that, we go back to our starting point, which is called a seed. The seed is that row 3, column 6 in this case. So our starting point is that 9, and our first 3 digits is 920. Is 920 between 1 and 435? The answer is no. So we go to the next set of 3 digits right under it, which is 095. 095, is that between 1 and 435? And the answer is yes. So we got our first our first 3 digits. Underneath that is 539. Is 539 between 1 and 435? No. 971 is underneath that? No. Okay, we go now to the top of the next column, which would be 481. That's the reason I had you draw the lines. So 481. Is that big enough? Too big? It's too big. It's above 435. So now we go down one. 982. Too big. 677. Too big. 593. Too big. 386. There's our next one because that's smaller than 435. Underneath that, 133. That fits. Back to the top. And we got 456. I'm hoping you guys are following because I really wish I could draw. 632. No. 420. Yes, that's our next number. Underneath 420, we got 480. Nope. 534. Nope. 200. Yes. There's our 5 numbers. But that's the importance of having a starting point so that we all get the exact same numbers. All right. We don't do R. And instead of stat crunch, I want you guys to do it with your calculator. So Toby, this is where you get to take over for a moment and please show them how to do this. I want the seed set with the calculator. Set the seed at 24. All right. Tanya, if you can pause it because this gives him time. When he's done, let's see if we don't come up with the same numbers. What I'm doing right now is I'm keying my own. All right, let's see if we match. According to my calculator, I see 389, 236, 178, 114, and 210. If not, it could be the difference the fact I'm using a newer calculator. My most important question is though, does all of yours match? If not, we'll have to figure that out. If so, good job, Toby. All right. So let's try it again. I'm going to delete that. All right. List is 45 presidents. Well, do we actually have 45 presidents? No, we have a 46. So pencil in number 46. So again, how can we draw? How can we choose? Draw names. Random number generator. Again, what? Calculator. Software. Table. All right. Just because I want this. I want you guys to see if you can draw 8 presidents, what 8 numbers it is, using the starting of row 2, column 4. Row 2, column 4, cross at a 4, and the first number is 46. So see if you can come up with the next 8 numbers. And Tanya, if you could pause for just a moment, give them a chance. And when you guys are, by the way, if you wrote down the same number twice, go back to the drawing board. Because can you invite the same person twice to the same dinner? The answer is no. Hopefully those are all the same numbers you got. If you're done, I think personally it's going to be a very interesting dinner because look at who all we're inviting. We're inviting 44, 45, and 46. That would be Obama, Trump, and Biden. Think of all 3 of those men sitting down to dinner together. Might be an interesting dinner. All right. Let's try it with your calculator. I'm going to leave the seed. No, let's change the seed. I want the seed set this time at 39. All right. I want you guys practicing at being able to do that. So, Mr. Toby, I hope you're handy dandy and ready for that. And can walk them through. All right, ladies and gents, hopefully you came up with the same of that. I came up 4, 18, 37, 14, 36, 15, 6, and 12 using a set seed of 39. If we're differing, we're gonna have to figure it out between my new model of calculator and yours. We could have an issue for grading later on, but that's okay. We'll figure it out. My biggest concern is what? Everyone there has the same numbers. So this is section 1.3. Again, I'm going to cut it off.